So in this problem, it says how many kilojoules of energy are released when 245 grams of water at 0 degrees Celsius freezes. So we need to think about our heating or cooling curve, and in this case, if something is freezing, then we are going to be cooling it off. So our curve is going to, the temperature is going to be going down as heat is being removed. Now, if the water is already at 0 degrees Celsius, then that is the temperature that the water is freezing at. So we don't actually need to know the amount of energy released as the temperature changed, because the temperature has already reached that critical point of 0 degrees Celsius. So all we need to know is how much energy is actually being released as the water freezes. So for pieces of the graph where we have a temperature change, we use Q equals m times C times delta T. But on parts of the graph where a phase change is happening, we don't have a change in temperature anymore. So we have to use Q equals the mass times delta H of either fusion or vaporization. And then in this case, our water is freezing, so we're going to use the value for delta H of fusion. Fusion being melting, but of course the opposite of melting would be freezing, which is what we're talking about here. So all we need to do is figure out the amount of heat energy released in this portion of the graph here, and we'll have our answer. So let's see, Q equals the mass, m, which is 245 grams. It's given in the problem, 245 grams, times our delta H of fusion value, which our delta H of fusion for water is on your Unit 4 formula sheet, and it's 334 joules per gram. So to use this value, we do have to have our mass. We have to have a mass in grams, which we do have our mass measured in grams in this problem. So we can just substitute in that delta H of fusion for water value, which is 334 joules per gram. So times 334 joules per gram. We're going to close those parentheses there. So when we multiply these two things together, we need to look at what is going to happen to our units. So grams, we have a grams in the numerator, and then we have grams in the denominator in joules per gram. So these two grams are going to cancel, and we're just going to be left with units of joules. Now that does make sense, because Q is, of course, energy, and joule is a unit of energy. But looking back at the problem, it says how many kilojoules. So we don't want our final answer to be in joules, we want it to be in kilojoules. So once we find this answer, it will be in joules, and we're going to have to use some dimensional analysis to convert it to kilojoules. Alright, so let's go ahead and do this in our calculator. 245 times 334, and that gives us 81830 joules. Okay, and then we can set up our joules to kilojoules conversion. It's just a metric conversion. So we have 81830 joules. And if we want joules to cancel, we're going to put that on bottom, and we want to convert to kilojoules. Kilo is, of course, the bigger unit, and joule is the base unit. So 1 kilojoule is going to be equal to 1,000 joules. So 81830 divided by 1,000. We're going to move that decimal point 3 times, so we get 81.830 kilojoules. Then our last step, we have it in kilojoules. Our last step is just to round correctly to significant figures. We look back at our problem. 245 has 3 significant figures, and then 0.0 has 2 significant figures. We are going to round our final answer to 2 significant figures. So we will keep the 8 and the 1, and then we'll look at that next digit to decide whether the 1 is going to stay a 1 or round up to a 2. Since the 8 is bigger than 5, we're going to round to 82 kilojoules. And that is our final answer.